We now continue with the presentation Advancing the Electrification of Heating Operations in Iron and Steel Making. As the industry moves toward carbon neutrality, electrification is emerging as one of the most effective pathways to reduce emissions and enhance process efficiency. Our next speaker is Mr. Gis Franklin White, R&D Manager for Application Development at Cantal AB. With extensive experience in industrial heating technologies, he leads projects that combine innovation, energy efficiency, and sustainability, helping drive the electrification of high-end temperature processes within the steel sector. Please welcome Mr. Gis Franklin White. A big round of applause to him, please.
Hello, and thank you for giving me the opportunity to speak about electrification. I'm a little bit early, so I guess we have time for lots of questions afterwards, I hope. But my name is Jesse White. Yes, my colleagues also here, Dilip and Rishi, helped put this together. Let's see if I can get this to work. Yeah, just a little bit about Cantal resistance heating technology. Cantal is an old company. About 90 years now I've been working on electric heating. So it's a well-established brand name and presence. We have about 9 production sites in the world: North America, Asia, and Europe. We have a wide range of products that we serve. I'll say a little bit about that just to give you an overview. But up to about 1850 degrees centigrade with our ceramic materials. We offer complete heating solutions for a wide range of industries. I'll get into that a little bit, explain, not just steel and iron and steel making. Just an idea of the range. So we have metallic heating materials. So we have, of course, nickel chromium is well known. Iron, chromium, aluminium alloys are a main part of our business. But also maybe lesser known silicon carbide heating elements that we produce. We have a plant in Perth in the UK. And then on the upper end of the temperature scale, we have molybdesilicide Cantal super elements that are used in high temperature applications. On the heating module and tube side, we have several different types of products. We have what's called super tall. We sell specialty tubes for different kinds of gas heating, electric heating. And on the other end, we have tubatol, it's called. It's a heating element that's protected in an outer tube. And flow heaters, I'll talk a bit about that in a little bit. We serve a whole wide range of industries, from furnace builders to end users. Not just steel making, as I mentioned. We have customers in solar wafer processing, semiconductors, glass industry is big, fiber optics, and then steel, which we'll delve into today. To mention some what we feel and are key benefits to electric heating, and then from experience as well. I think it's good to point out the benefits. Well, firstly, we talk about CO2 emissions, of course. We have the potential with electric heating to significantly reduce CO2 emissions. And if you have renewable energy, like in Sweden, you can even get down to almost zero. And that's a big driver. But maybe less discussed here is also elimination of other pollutants. We talk about NOx, SOx emissions from fossil fuel combustion is also something that one can reduce dramatically with electric heating. Another key advantage we feel with electric heating is efficiency. In certain applications, you can get up to 95% energy efficiency. In particular, I talk about electric gas heating, which I'll talk in more detail about. That's a main advantage. You can reduce OPEX. Another advantage, too, is temperature control. Certain applications require very precise temperature control. With electric heating, you're able to have a much more precise control of your energy input, and that's a major advantage. Another maybe lesser known advantage is working environment. we see where we replace gas burners with electric heating that we significantly reduce, for example, ambient noise. So noise levels are reduced dramatically with electric heating. For example, in a ladle heater, which I'll talk about, you can hear the difference on the shop floor. It's much quieter with electric heating as opposed to burners, which have a lot of gas flow and noise. And lastly, it's also possible with electric heating to have controlled atmosphere in a furnace. This could be an advantage where you want to have less oxidation, for example, on shapes, forms. So that's also an advantage we see certain customers are looking for that. So just to sum up, what we feel the key benefits of electric heating. To delve into more of the areas where we're working on developing electric heating technologies for steel making, iron and steel making, across the whole value chain, really, from iron making to reheating furnaces, for example. We have working on different areas here. I don't know, you can't really see we have gas heating. I'll talk about that last, actually. But this is it's a big area we're doing a lot of technological development at the moment. And in these other areas where we're actually applying existing products that we have in retrofitting, for example, certain unit operations. I'll talk about that. Reheating and annealing. With ladle and tonnage heating, it's more of a technological development as well. It's the scale up that's the challenge. From small ladles to very large ladles that are used in steel making operations. So ladle heating, we'll talk about that a little bit. We've partnered up with a company called Sheba, and we're working together to develop complete turnkey ladle heating solutions to end users. Not just in steel making, it's before steel making. There's a lot of focus on aluminum industry. The smaller ladles, a little easier to build electric ladle heaters, but also foundries and other metals. The challenge there, and we're working on, is scaling up that, as I already mentioned. Up to say over greater than 100-ton ladles is a technological challenge that we're trying to meet. Where you're using radiant heating to heat a big volume there, it may end up requiring a combination of radiant and convective heating in these applications. So we'll see how that evolves. Just to give you an idea of right now where we're at in development. Of course, for ladle heating, drying and preheating applications are the focus there. They can have different designs. We can use our range of heating elements that we have. Silicon carbide and molybdenum being the most common there to use for ladle heating. But also metallic on the lower temperature range. Metallic heating elements can go up to about, say, 1200 degrees, where you can use a metallic heating element. Above that, you need ceramic materials, either silicon carbide or molybdenum. So this is a picture of a unit we delivered together with Sheba, and you can see these are silicon carbide heating elements hanging down from the top lid there. So far, we developed and delivered preheaters up to about 60-ton ladle size. So it's going up in scale. We see a progress there, and looking at that, it's about a 3-meter inner diameter ladle, and pretty deep. So you say a max refractory temperature of about 1300 degrees there. I'll touch a little bit on reheating furnaces. That's also an area we're working on actively. Of course, it's a different challenge, a different type of heating required. Of course, here you're heating slabs, billets, other forms. Traditionally, it's gas-fired. It's a high energy or high power size on these furnaces, 10 to 50 megawatts. A high power density and temperature, so it's a challenge from a technological standpoint. So far, we've validated heating in this application in our own facilities at Kanthal. We have our own production facility in Hallstahammar, and I'll say a little bit about that. But before that, as mentioned, this was a project that was done in Sweden, sponsored by Vinnova, with some other steel end users, being SSAB, for example. It's called the Ellros project. It focused on combining actually resistance heating with induction heating. An interesting project. So the tests were done in Svevia and Luleå in northern Sweden, where we combined induction heating with the resistance heating. And we tested a wide range of materials from carbon steels up to austenitic stainless steels to see how to work. I won't go into too much detail, but some salient conclusions are that resistive heating has a lower energy use and it's suitable for a wide range of materials. That can be established. Induction heating has its advantages for sure. And it's certainly suitable if you want a fast production rate, if you want a fast heating rate. Definitely induction has a clear advantage there, no doubt. Not as suitable, we found, for austenitic materials, where you have where you take up that energy from the RF coil. But there are advantages to induction heating. Let's see here. Yeah. One maybe drawback from induction heating is you have to have, of course, a cooler coil, and there's some energy losses involved there, so it's a little bit different energy balance than you have with resistance heating. But all in all, it's we show that resistance heating has good energy efficiency, even for reheating furnaces. Just a case story, a couple of case stories there. We have a furnace for billet heating at Kanthal, at our facility there. We have a walking beam furnace there, up to about 1270 degrees centigrade with air. Billet size is, they're not large billets, and they're not a large furnace, but say 8 tons per hour. It's about 2.2 megawatts installed power. It's, as you can see from the picture here, it's hanging Kanthal Super Elements. We've had it in operation for over 10 years now, and with great success. We found that there are many advantages to going electric here on this application. One in particular, the predictive maintenance and lifetimes for the system. It's also very quiet, and it's been very stable. So we're pretty happy with that. Another case story is a pit furnace for ingot heating. We also installed here up to about 1320 using Kanthal Super Elements. We have about 9-ton charge weight. Works quite well. We've had for several years. Continuous annealing, I'll say a little bit about that. One that here is a retrofit. We can replace gas burners, tubes, W, U, and P type directly with what we call Tubatol or Kanthal radiant tube systems. We've had successful installations at 2 customers for annealing. And then there's plans in these customers to extend their electrification in their furnaces. Lastly, I'll talk about electric process gas heating. I think this is worth spending a little more time on. We're working actively here and putting a lot of effort to develop electrical gas heating. We have 3 technologies that we're developing in parallel. We have a direct heating technology that's it's a very high energy density, and it's modular design. This is from the hybrid project. This is a spin-off, actually. This type of technology. It has its advantages. We have an indirect heating technology we're also working on. This is where we actually have the heating elements are protected by a metallic barrier. Disadvantages with that, you have maybe a lower power density, but then for particulate, it seems to work quite well with when you have particulate in your system, where you don't have any type of accumulation on the heating elements themselves from particulate. We have one, Protal FH, the last one here. It's also a direct heating technology. We've had this on the market for several years now. Fairly small scale for steel making, but we're moving up to 1 megawatt in size here. And in comparison here, we're looking at, for DRI, I'll say a little bit about that. We have a strategic partnership with Danieli, working on this Protal DH, the first one, direct heating technology. The objective there is to industrialize this DH technology for DRI. The focus there is actually natural gas hydrogen mixtures, retrofitting, for example. We feel there's a big market for converting plants. Danieli claims up to 30% of emissions can be reduced just by converting to electric heating of process gases. And that's a pragmatic approach to reducing the CO2 footprint for sure, instead of going pure hydrogen. Just some comments on further development. Yes, I talked about this is offspring from hybrid. We're working on further development with Danieli on that. We have a test facility also at Sverim in Luleå, as you can see in the picture here. We successfully heated hydrogen up to about, say, 1050 degrees centigrade at 6 bar. It's a rather small system compared to what we were endeavored to build here, 225 kilowatts, but we have a recirculation system and we can test our development of our heating technology. Going on, we have a pilot heater module that's going to be installed. It's in alignment with this Hydra project, EU project, also together with Danieli. That installation has been done. It'll start up in January 2026. Heating of hydrogen and natural gas mixtures is the effort there. And then we're building a demo scale model or a system larger than 1 megawatt, this Protal DH, in Abu Dhabi at Emirates Steel. We have an agreement there. We plan to deliver that January of next year. So that's in motion now. So hopefully we'll be successful. Just to summarize, as I've discussed, electric heating is definitely a key enabler to reduce emissions, not just CO2, but NOx and SOx. There's a good potential to replace fossil-fired heating in steel making and iron making for sure. Benefits, as I touched on, efficiency, productivity, precise temperature control, and not the least, improved working environment. There's a challenge. We have some challenges ahead of us. A need to develop energy-intense megawatt-sized solutions is a big challenge. How to scale these technologies up. And at present, we're trying to do just that. We're trying to scale up, for example, with Danieli. So, thank you. Open for questions.
Mr. White, we have some questions for you. We have seen that there is a scalability problem with heating on ladles, but there is a smaller element you have not talked about, tan dishes.
Yeah.
Do you have any solution for electrical heating of tan dishes?
Well, that's a great question. Yes, we do. We haven't worked on it as actively as with ladles. Our focus right now it's been mostly on ladles, but yes, we're working on tan dish heating solutions, electrical tan dish heating solutions. So hopefully in another time I'll be able to discuss more about that and describe what we're working on that side.
Thank you. From your experience at Cantal, how can industry balance energy efficiency with the need for reliability and process stability when switching from fossil fuels to electric heating?
That's a good question. I think with electric heating, we see, well, maybe I'll try to answer, it's a complex answer maybe. And we can see we have advantages, of course, with process efficiency with electric heating. I think there will be challenges, not only scale up, but also developing industrial robust solutions that last a long time and can take abuse. I think that's a big area. Maintenance will be an issue. How do we maintain these systems? I'm talking mostly about process gas heating right now. These systems have a very high availability, 99%. We have to develop them modularly so we can have modules will go out, they'll fail. We have to be able to have a system where we can keep it in operation by switching out modules. So there's a lot of engineering yet to be done there in order to develop systems that we think will hold and be cost-effective OpEx in the long run. So we have our work ahead of us still, for sure.
Thank you. And the last one, looking ahead, do you see electrification as a standalone solution, or will it need to be combined with other technologies such as hydrogen or CCUS to reach full decarbonization?
It's a great question. We see it as there'll be hybrid solutions, not just, I mean, electric, you can have different ways you can heat electrically. So there's one advantage you could have with electric. You could have a hybrid system. You can have a flex system. One thing that Daniele and ourselves are working on is maybe not a complete conversion from gas-fired process gas heating to electric. There's some end users that would like a system where they can flex. For example, if there's a price differential on energy costs, electricity, maybe they want to run electric at night, for example. A system that's flexible is an advantage. So we see that there will be probably hybrid solutions, especially going forward in the next steps, not just a complete conversion to electric. We want to be in a position where you can actually have a combination of different technologies there.
Thank you very much for your presentation and to be with us today. Thank you very much. A big round of applause to him.